The industrial tomato supply chain is one of the symbolic sectors of the Italian agri-food industry. Italy indeed ranks third as a world processor with more than 5.3 million tons of processed tomatoes, right after China and the United States. During this Macfrut Academy video lesson, we'll take a journey throughout the value chain of industrial tomatoes, following their development starting from varietal research through nursery technologies up to the planting and harvesting of the products that are then sent for processing. Without further ado, let's get started. Being the industrial tomato supply chain quite a complex one, it can only start from the seed. Through genetic improvement, this sector is able to tackle multiple agronomic and market challenges. Seed companies work on varietal innovation, and the hybrid varieties that producers can choose from are often developed starting from the needs of individual countries and specific production areas. Several parameters have to be considered for varietal selection, such as the ripening cycle, in order to design a strategic harvest calendar for the industry that includes early and late varieties. Then, the selected tomatoes need to be suitable for the soil and climate conditions of the cultivation area, meaning that soil testing and an assessment of water availability are essential. Then, depending on the desired agronomic strategy, the variety with the most suitable vigor is identified. Resistance is gaining more and more importance. Tomatoes must face nematodes, bacteriosis and virosis. Resistant plants help to protect productivity and are also beneficial in terms of sustainability. Therefore, varietal selection has to be made by taking multiple needs into consideration: the organoleptic quality of the tomato, yield, ripening period, water and nutritional requirements, and resistance to plant diseases and insects. This is exactly the scope of varietal research at a global level, as confirmed by one of the international seed companies that has invested the most in the development of industrial tomatoes.
One of the breeding objectives that we have here at HM Claus is to identify which varieties of new processing tomatoes have disease resistance, that can have really good fruit quality, that is able to have really good plant agronomics in the field when the growers grow them in many different types of conditions. What I do as the breeder is I will create new parents that have specific disease resistances or have really good fruit quality and chemistry. I will cross those parents to create a hybrid, which you see many hundreds of hybrids here out in this field. And the very first year, we'll trial those hybrids in the grower's field so that we can see how well they perform in the country of interest. Specifically, we're here in Italy and looking to see whether or not the hybrids that I've created work well in Italy. I also breed globally, so I, as a breeder, will look at many different trials in Italy in the north, Italy in the south, Spain, Portugal, Brazil, South America, and also California. One of the techniques that many companies, breeding programs use in order to breed for processing tomatoes in Italy, we have this challenge of different foliar diseases or plant diseases that occurs only in one specific country. And so when we are creating new parents and new hybrids in a different part of the world, what we have to do is trial those hybrids in the region specifically to see if those diseases actually have an effect onto the new hybrids. And then once we get the performance of the hybrid in the field, then we can identify which parents are good, okay, or bad. And then from that, I use what we call general combining ability and statistical analyses to identify if a parent is good, let's start making more hybrids for that. If a parent's okay, then I need to go back to the drawing board, fix whatever major mistake that parent has or major flaw that parent has, and make more hybrids from that after I fix that flaw. For example, yield can only be evaluated with hybrids, so how much fruit a plant produces, and yield performance of a hybrid is what tells me whether or not a parent has good combining ability for yield. So here in North Italy, in the Parma and Piacenza area, there is a high pressure of disease for Peronospora, bacterial speck, and versus in California, my breeding program there has a lot of pressure with Fusarium in the root and the stem, and then also falciforme and spotted wilt. Versus in Spain and Portugal, we have some similar but yet different diseases that we need to focus on and target as well between Italy and California. Another challenge that we have globally is the amount of water availability in different growing regions. So, for example, in California, in other parts of the world, there'd be multiple years of drought. And when you have more strain on the water sources, it can also result in higher salinity and more stress when you pull more water from the well versus fresh water and so forth. And that causes a lot of stress on the plants, in addition to having less water as well. And so one of the effective ways to battle that is to make sure that we are trialing both our breeder trials, but also our product development trials in the regions that have low water, in the regions that have high water, and have as many trials as possible so that we can assess a new hybrid that we're trying to create can still perform under those more water stress scenarios.
How is the breeding activity developed and what kind of technology does research need?
In addition to my breeding program, but other global companies are also using statistics of the performance of a hybrid and or inbreds in the field of the plant and the fruit in combination with large-scale genomic data to identify whether or not something will perform well before we even create it. So this breeding technique has been around for quite a long time now, but it is now more routinely becoming implemented into a lot of global breeding programs. But there's one caveat that even though we try to predict how a hybrid is going to perform, we always need to be testing in the field and identifying that what we predicted is actually performing in the field. So, like many other programs, we're looking at a hybrid approach using the statistics and the analytics in combination with being in the field and identifying whether or not something is performing well. And this is where grower collaboration comes in handy, because we are able to put our trials into growers' fields and identify for that particular grower whether or not a new hybrid is going to perform for them, but also it gives us an opportunity to have larger data sets and identify a larger amount of hybrids in the field to run those statistical models in the future.
One of the other challenges that we have in breeding is how long it takes to identify a problem, let's say for a new disease coming up, and how long it takes to identify new resistance, and then start creating a new parent, and then create a hybrid and multiple hybrids, trial them into the field for many years, and then commercially launch. You can imagine that is many, many years of both research and development, and then it can be in a grower's field commercially.
Technology is proving to be a valid ally of varietal innovation.
One thing that using more predictive analytics or marker-assisted genotyping and trialing multiple times a year, that all helps us try to speed up the process, going from something like 10 years of development to a much shorter amount of time.
We also look at the firmness. You can imagine that when you harvest tomatoes, you need decent amount of firmness so that when you go to take it to the processing factory, it does not completely disintegrate and smush under the pressure. But you also need some firmness to dice up if you're making a diced product as well. We will also look at productivity, of course. You want to be able to put the amount of water and the amount of resources into your field and obtain fruit rather than just plant. And so we do want to have an adequate amount of yield. We also look at how well does the plant perform in health in many, many different types of trials. How well does the plant size and architecture perform in a grower's field?
Italy is a key country for industrial tomatoes. HM Claus has invested in this crop for a long time and developed a close collaboration with US-based researchers. HM Claus invests in industrial tomatoes in Italy, with many research tests located in the typical areas of Emilia-Romagna, but also in southern Italy, specifically in the Apulia region. This sort of research is mainly carried out in the field, under real cultivation conditions by producers themselves, in close collaboration with them and with the processing plants they work with. Many are the parties involved in research on industrial tomatoes. First of all, we have producers, who need to be guaranteed a substantial yield and high-quality fruit. Processing is also another aspect to take into account. So the fruit needs to be easy to process and of a high quality to meet the requirements of the processing plant. And then the final product obviously needs to meet consumer expectations, with its taste matching that of Italian industrial tomatoes. On the other hand, there is plant yield. On the other is plant health. Varietal development has to keep this balance. We are trying to meet the new needs of industrial tomatoes in terms of genetic resistance and the ability to adapt to high temperatures, which are increasing year after year. The quality of the fruit is pivotal in our research, so we look for a nice internal and external color of the berry. This is influenced by the Brix value, that is an important quality factor for many processing plants in Italy. Then we're also looking for other important characteristics, such as the pH level, which is linked to industrial processing. We work with the two most common types of tomatoes in Italy, that is, slightly square-shaped and oblong. The former is typical all over Italy, whereas we mainly focus on the Apulia region for the latter. We try to select the plant material in the main cultivation areas precisely to test the new genetic material under real cultivation conditions. So we pay close attention to a lot of aspects, such as resistance to diseases, like Peronospora in northern Italy, for instance, or Alternaria and spotted wilt in southern Itoly. Every single research test consists of hundreds of new hybrids and includes reference cases, namely the most commonly grown varieties of a given cultivation area. Through this research activity, several successful varieties have been introduced to the tomato market and industry over the years, starting from the first two varieties, Pietrarossa and Dress, with other varieties joining the market and gradually becoming more important, such as Pumatis and Lenotrio, and last but not least, Addenda and Orso Rosso. These varieties are gaining ground year after year and are very satisfactory both for producers and the industry. This is how we work and develop new selections. Addenda F1 is HM Claus's new variety of square-shaped industrial tomato. It was mainly created for southern areas, but can also adapt very well in the north of Italy. Addenda F1 tomatoes are early and tasty, as well as ideal for late transplantation thanks to their short cycle and fast ripening. Addenda is HM Claus Italy's latest varietal innovation. As a variety, it has a medium early cycle, so it adapts well both early in the season and for late transplantation. The cycle of this variety is not very long and ends before the rainy season. Plants of this variety are lush and leafy, but have a short and compact internode, so harvesting is easy both mechanically and manually, the latter being traditionally done in the area of Foggia. Addenda tomatoes are square-shaped, large berries that have good firmness, a bright red color, and very high Brix value. The fruit can be preserved for up to 5 days in the field when overripe, so you don't need to harvest immediately when the rain prevents you from bringing machinery to the field or when other fields are ready to be harvested and you can only access the Addenda field at a later stage. As a variety, Addenda is very flexible, versatile and suitable for several cultivation areas. As a matter of fact, it is extremely successful in Italy, both in the south, especially in the Campania area, and in the north, in the area of Parma and Piacenza, but also elsewhere in Europe, as it is not an exclusive variety for Italy, rather it is sold in other countries. Another very interesting feature of Addenda is its resistance to the tomato spotted wilt virus, which allows you to grow it even where the incidence of this pathogen is very high. While selecting the right variety is a fundamental condition, it is not enough to guarantee a satisfactory production in terms of quantity and quality. Before they become healthy plants that can be transplanted, seeds must go through several steps. These are very delicate operations and they risk jeopardizing the production campaign if they're not carried out correctly. This is why it is essential to rely on experts who are able to provide the right infrastructure and to recommend the best solutions based on the climatic and light conditions of the area. To shed light on the most delicate steps and the pitfalls to avoid, we turn to Idromeccanica Lucchini, an Italian company that has been designing and manufacturing plastic-covered greenhouses for horticulture and floriculture for over 70 years. After selecting the seed, we go to the seeding line. Seeds have to be sown in suitable trays. Once this is done, we move to a germination chamber. This is a fully closed, fully controlled environment within which suitable climatic conditions are created to ensure seeds can bloom and germinate. This requires the right light and climate conditions, particularly heat, humidity and ventilation. When it comes to germination, the germination chamber is essential. It's the environment where seeds germinate. The size of the space has to be suitable for the number of trays that you want to germinate at the same time. What are the ideal conditions for germination and what factors are key? Well, first of all, space, the environment, volume and insulation, because the temperatures and climate conditions inside this environment have to be different from what is outside. Suitable climate conditions for a plant include light, temperature, humidity, and of course ventilation. Flexibility is also something to take into account. Producers or growers need to have a certain flexibility to be able to do what they want. Lighting is also very important. Having the right micromolds for a plant, the right LEDs with the right infrared you need and the right temperature. Producers have to be able to get the temperature they want, 25 degrees, 30 degrees, 20 degrees, based on what has to germinate. Humidity is essential. It all starts from that, because humidity nourishes and irrigates the plants, and it also fosters the perfect conditions to germinate. Once germination is done, plants are transferred to a nursery greenhouse where they keep growing until they reach the right maturity to be transplanted into the fields. When designing the structure of a greenhouse, you have to factor in the right size, temperature management, the ability to withstand bad weather conditions, and above all, light. All these factors are geographically dependent factors. If you're in Northern Europe, you're going to have issues with light, for instance. Therefore, direct lighting is important. So, based on the type of covering chosen by clients, you may have glass or plastic sheeting for a high transmittance, because you need light. However, if you were to place the same greenhouse in Southern Europe, or even further south in North Africa, or in more tropical environments, you're going to have too much light, which you'll have to partially reduce by opting for light diffusing covering materials. That is where you need to diffuse light so as not to burn the leaves of the plants, unlike Northern Europe, where more light is necessary instead. You need to take this into account if you want to build a suitable nursery, in addition to thermicity, when choosing the right covering size. If you're in a cold environment like Northern Europe, the thermal conductivity of the insulation material used for covering has to be good. For example, double-layer insulation ensures much better insulation than simple plastic sheeting or glass covering. Insulation materials are very popular in Northern Europe. Not only can they be used to insulate, but they are also very useful to manage and regulate light inside greenhouses. We think that this automated insulation and shading system is essential, because it allows us to adjust light, to manage light, as well as to save energy through insulation. Another important factor when designing a nursery is the climate. You need to make sure that the plants are put in the most suitable and favorable climate conditions to grow properly. And this is why temperature, humidity, and ventilation are essential. The volume of a greenhouse must be designed and calculated so as to ensure that these parameters are met as much as possible. As I mentioned, you also need temperature control, and it needs to be based on external factors. If a greenhouse is located in Northern Europe, the climate will be unfavorable, and temperatures outside might even drop to as low as -15, -20 or -30. Inside the greenhouse, you may want to have 20 or 25 degrees. So you need to have the right heating system, which can work on hot water or hot air depending on your needs, as well as the right ventilation and humidity management. These are fundamental factors, and nurseries are essential to have the best conditions. Plants have to be as healthy as possible. And this is how you also get a healthier, more efficient and more profitable transplantation. These are all aspects that have to be taken into consideration and taken care of by professionals. This is exactly why we have engineers and thermotechnics experts in our workforce here at Lucchini, who deal with all these important aspects. When a plant is ready, it is transplanted into the field using transplanting machines. For optimal yield, you need to manage plant nutrition well, that is, water and fertilizer. While sprinkler irrigation systems were used in the past, fertigation, that is, supplying water and nutrients directly to the root system through drip lines, is much more common today. This results in significant water savings and an efficient use of fertilizers. In addition to light drip lines, irrigation systems are equipped with a filter, which is one of the most important components in drip irrigation for industrial tomatoes. This originates from the need to use water, which in most cases is not pure. So we have to clean it as much as possible because the drip lines have tiny openings, which is something that calls for very clean water. Another important component of drip irrigation systems is the fertilizer injection system. This can either be quite simple, such as a fertilizer tank, or more complex, with fertilizer being measured out proportionally so as to know the exact quantity you are using. Then, on top of this, there are other accessories, such as the main supply hose, fittings, and anything else you need to have a complete irrigation system. At Lucchini, we are working to enhance our irrigation systems with technology by adding soil moisture sensors to measure the amount of water at root level, and also electrical conductivity sensors to check for nutrients. Through these sensors, we know whether a specific irrigation cycle or the fertilizer we are providing is enough. In other words, this means knowing when the amount of nutrients we are giving is right and when we risk wasting products with longer irrigation or fertigation sessions. And why do we do that? This emerges from the need to be increasingly careful when using water and nutrients in the future in order to maximize industrial tomato yield even more. When the percentage of fully ripe berries on a tomato plant is high, it's time to harvest. Mechanical harvesting is what makes modern industrial tomato production stand out and is now common in the main production areas. Harvesters have been at the center of an important technological evolution, which led to improved performance in the field, supporting producers in their work while also making processing tasks easier. Before we break down how mechanical harvesters work, here are some things to remember to ensure proper functioning. For smooth operation, the ground has to be flat without deep furrows to prevent dirt or other substances from getting into the machine. Something else you need to pay attention to is weeds, which have to be kept to a minimum to avoid overloading the threshing system. During harvest, it is important that the soil is well drained. Waterlogging needs to be avoided as it can interfere with harvesters moving forward and other vehicles transporting the products. Using drip irrigation for tomato plants does not cause issues during harvest, especially if the hose is underground. When this is the case, you can also opt for an easy removal once you're done harvesting rather than before. To know more about the mechanical harvesting of tomatoes, we have partnered with Guaresi, an Italian company specialized in the design, production and assembly of tomato harvesters, headquartered in Italy in the province of Ferrara. This is where Guaresi's engineers and designers work with the latest 3D design platforms to develop cutting-edge technological solutions, such as the new Super G La Guaresi presented at EIMA 2024. Before field operations start, the harvester is positioned in front of the rows. The harvester header is lowered and can also harvest tomatoes in a double row. The new version of this machine has a reduced angle of incidence with the ground to pick up less soil and ensure smoother movements, making it easier to operate. A floating cutter bar pulls up the plants. They are loaded onto an in-feed belt conveyor and moved towards the shaker, with better positioned rubber rollers resulting in improved feeding. This is where the vegetative part of the plants gets separated from the berry. The shaking and the rubber fingers of the machine make the tomatoes fall onto a second conveyor belt, while the plants keep moving on the first belt towards the rear vine chopper. This system shreds the stems, resulting in easier post-harvest operations and clean fields, and frees you from the need to have another machine just for shredding. Let's go back to the second conveyor belt, the one with freshly picked red and green tomatoes. Here is a fan to clean the products and a smooth cleaner roller mounted on a cross conveyor which removes any remaining leaf. At this point, tomatoes reach the separator. The products are sorted by weight by a pre-sort feeding belt with rods and no cleats, a Guaresi exclusive. This device guarantees uniform feeding to the following two optical sorters. Any green tomato is discarded, while red tomatoes moved forward on the sorting belt, with a worker present on the machine checking them one last time. The optical sorter comes with a new algorithm and a machine learning system. It can be adjusted and monitored directly from the driver's dashboard. Red tomatoes are then carried onto the discharge conveyor equipped with higher cleats and a double hydraulic articulation. There are several options to unload products collected by mechanical harvesters. For instance, they can be unloaded directly into trailers ready to be transported to processing plants. This solution is certainly ideal if conditions permit. Otherwise, they can be moved using steel boxes that will be loaded on a truck for transport. Tipping trailers suitable for continuous unloading of the harvesters are also popular, as they can move the products into trailer trucks for road transport. Harvest speed varies depending on the characteristics of the soil and the amount of tomatoes present. When using precision settings, therefore for slower work, the machine can reach a speed of 3.5–3.8 km per hour in southern Italy and up to 5.5–6 km per hour in northern Italy when the soil conditions are optimal. Super G has been designed for improved comfort, safety and technology and comes with aesthetic features on the side of the harvester that are symbolic of the new Guaresi machine. It is equipped with an air-conditioned double-seat cabin with improved visibility. It can be controlled remotely and is able to communicate with a field mapping system. Mechanical harvesting becomes almost a digital harvest, with the implementation of a cruise control system equipped with 4 cameras and multiple safety sensors. The joystick and the dashboard communicate with the harvesting system through isobus technology, with all data being made available in the cloud. This is important information for the declarations of conformity that the grower needs to comply with, but also to ensure monitoring and compliance with production standards. From varietal research to mechanical harvesting, the industrial tomato supply chain is focusing heavily on innovation, with investments to optimize production and make the sector competitive. This journey into the world of industrial tomatoes has come to an end. In the meantime, you can keep up with Macfrut on our social media platforms and get real-time updates. You'll find us on LinkedIn, Facebook and Instagram. We'll see you again next time.